Hello again. So today I'm going to go a little hands-on with arrays. So let me begin. I have an empty project over here. I'm calling this one array demo. And so let's begin by creating an integer array. I'm going to call this one A, and I'm giving it size 5. And going to print out some of these values. So A0 contains space, and I'm going to put in a placeholder, and in that place I'm going to print out the value of the first element of the array. And I can do the same thing for the zeroth, for the first, second, third, and fourth element, just like that. Now if I run it like this, remember I still have not assigned any value to any element of array A. So what I'm going to see here is basically kind of going to be unpredictable. Just to get you into the habit, this is a main function that returns an integer, so I'm going to return the value 0. And there you go. You see A0 contains, this is not right, it should be A1, A2, A3, and A4. And in any case, you see that the values I'm seeing over here, I mean, I never assigned these. I never saw these values. So in order to show you how to actually use elements of an array, let me assign them some values over here. So maybe 10 to the first, to the 0th element, 20, 22, 27, and to the fourth and last one, 33. Okay. And so remember, this is an integer array, which means of size 5, which means this is basically 5 integers named A0, A1, A2, A3, and A4 in a row. I'm going to print these out. There you go. A0 contains 10. A1 contains 20, A2 contains 22, A3 contains 27, and A4 contains 33. All the 5 values that I've assigned to these 5 array elements over here. So let me try something else. So just like I can create an integer array, it's just as easy to make an array of another data type. So let me change the int data type to a float. And just to show you that this actually works, I'm going to assign some fractional numbers over here. So 10.2, 20.5, 22.75, 27.6, and 33.33. Okay. I'm sorry, forgot something. Yep. Now I changed the data type to floating point numbers, so this has to be changed. These have to be changed to an F. Okay, let's try that again. There you go. 10.2, 20.5, 22.75, 27.6, and 33.33. You'll notice something funky over here. The last one, I assigned 33.33, but when I print it out, it shows the value 33.330002. I did not assign that 2 over there. And the reason we're seeing this is that floating point numbers do not store If the number is very small or very large, floating point variables do not necessarily always store the exact value that you assign them. And that has to do with the way in which uh, the bits in a floating point variable are used to store a number. You can store numbers over a much larger range, but the values that you store are approximate. Okay. Now, for many, I foresee for the kinds of assignments that we'll be doing, that usually won't matter much. But if you're going into like very small or very large numbers, then it starts to make a difference. You saw from the output over here, we saw these many six digits after the decimal point. Let's say I want to control that. Just as a reminder, I can do that. Say I only want to print 3 decimals after digits after the decimal point. So I can just insert 0.3 between the percentage and F in the floating point number placeholder over here. And let me just try that again. There you go. Much nicer looking. 10.200, 20.500, 22.750, 27.600, 33.330. So we did that before. I'm just showing it to you again over here. You will also remember that we talked about the value that a variable stores. And also that there's another thing associated with a variable, and that is the address, the location in memory at which that variable exists. Now, we haven't looked at that yet, but we'll look at it now. What if I'd like to actually see the address, the memory address of a variable? Well, we already know how to access that. And let's say I modify the string now, and I set it to something like I want to print out the address, and then I want to print out the string I'm printing out right now. So let's say before the colon, I want to print out the address of that variable A0 on this line, on this particular line. Now, one way to do that is I can print out the address as a decimal number. Okay, so which means I'm adding another placeholder in this string, which means I have to add in something over here that will basically print out the address of A0, and I can do that like this. Simply add an ampersand before A0, just like I would do for any other variable. Okay, so this is not array specific, what I'm doing right now. So let me do that for the other rows as well, because there's a point to this and I want to show you something. Okay. And just to make this visually more interesting looking, like this. So 2 colons in between. So I'll print out the address as a decimal number, space, 2 colons, and then A0 contains, and then whatever value is stored in there. And I have to insert something like this for all these other rows now. And of course, change the indices of array elements to 1, 2, 3, 4. There you go. So now when I run this code, in this place over here, we will see the address of array element, of the 0th array element. And after that, after the string, we'll see its value like we did before. And similarly for the other 4. There you go. And you'll notice something. Remember that we are working with integers, floating point numbers right now. And the size of a floating point number, if you remember on my machine, is 4 bytes. Every byte has a unique address in a PC. So you can see that the starting address of the first element A0 of the array is blah 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 92, and the address of the next element of the array is 96, and the difference between the two is 4, and the next one is at 796, and then the next one is at 800, a difference of 4 again, and the third element is at 804, and the one after that at 808. So they're all located right next to each other, like I showed you in the theory part of the slides. Okay, so you see I'm printing out the address right now as a decimal number. Sure, I can do that. But usually when we deal with memory addresses, usually we like to display them as hexadecimal numbers, base 16 numbers. To do that, instead of formatting the output as a %d decimal number, what I can do is I can print out the same value, the address of each of these array elements. I can print them out as hexadecimal numbers by using a different placeholder. And that different placeholder that will show this number as a hexadecimal number is %x. And here you see the same memory addresses, but this time displayed as hexadecimal numbers. Later on in your program, when you study computer organization, you will learn how hexadecimal addresses are actually the more natural way to handle, to view addresses. Now, this is not the end. So sure, you can look at an address as a hexadecimal number, fine. But you can. There's also another way to format addresses specifically, and for that we have a placeholder %p. P stands for pointer. Pointer is in C lingo. Pointer is basically another word for address. Pointer. Okay, so so %p for pointer formatting, and %x for hexadecimal number formatting. So let me run the same code again, but this time let me use the %p formatting string because I know what I'm printing is actually an address. Let's see what that looks like. Still going to be a hexadecimal number, but you see that there are some leading zeros in the address. The address does not start at the sixth digit. Actually, the address is much longer. The thing is that the first 8 bits of the address actually happen to be 0, which means in hexadecimal format there are 2 leading zeros in this particular address. So I just want to continue over here. I'm just going to show you one special type of array, and that is an array of characters. So let me create another one over here, character. Let's call this one text, and this one has size 10, and I'm going to start off with something very similar. I am going to print out so before assigning, well, actually, let me skip that step. So let me print out the elements, the 10 elements of this particular array. I'm going to do some copy pasting. So if I run this, this will print out the 10 characters in this character array that I call text. And you see that I have not assigned any value to any of these elements. I have not initialized the elements of this array, which means I will, just like for the integer array above, I will see some weird stuff, some weird contents, right? So let me just run this once. There you go. You can see it's some very weird looking characters over there. So now let me initialize at least some of these elements with some something that we recognize. So I have initialized the first 6 elements of the array text. The first one contains the character capital H. Second one contains the character E, small l, O, and an exclamation mark. If I run the same code again and I print out all of these characters over here, I should be able to see HELLO, hello, exclamation mark, and after that, well, after that I'll see the same crap I saw before. Well, that's nice. But you see that in order to print out 6 characters, I am using 10 lines of code to print out all the elements of this character array text. There's actually a simpler way of doing that. Let me show you that now. So you can put a new line after the last one over here. And so let me show you this other way of printing out specifically character arrays. Okay. There's another special placeholder, %s. %s is short for string. And what it does is you can give it a character array, the name of a character array, in this case text. And what it'll do is it will print out all of the characters of text in one line. One line of code will do the same thing that these 10 lines are doing over here. So let me put in a new line after that, and let me show you what this looks like. There you go. Hello, this is produced, the first line of output is produced by the 10 printf statements, and then after that I have hello, and then I have many more characters after that. And the reason I have many more characters after that, more than 10 even, is because the printf statement, or let's say the printf statement, does not know the size of the text array. It doesn't know that it is 10 characters long. So it basically looks into memory and starts printing until things still make sense. Now there's a way to fix that. Let me show you how. Remember in the ASCII table that we saw when we were looking at characters, there was one character that was kind of special. It was called the null character. One function of the null character, which is, by the way, represented by all 0 bits. One function of the null character is that it is used to mark the end of a string, or basically it marks the last character in a string of characters. Everything after that will be considered garbage by some functions. And one of those functions is the printf function when I'm printing out a string like this. So let me keep these 10 printf statements over here, but let me show you the behavior of this printf statement with the %s placeholder over here when I now try to print out the text array. We'll see something different. There you go. You see? So when I'm printing out all 10 characters, it's printing whatever is in the location of elements 7, 8, and 9 of the text array. That's why I still see these 3 weird characters over here. But the second time I'm printing out using the %s placeholder, what the printf statement is doing is it only prints all the characters in the text array until we get to the null character. And the null character is interpreted as the end of the message contained in this character array text. And anything after that is simply not printed. And as you can see, that makes for much cleaner, much more common sense output. We will talk a lot more about arrays of characters, also known as strings, near the end of the semester. But for now, since we were talking about arrays, I wanted to show you how character arrays are a little bit special and how you can make it easy, how it's easier to work with them if you're using the printf statement. And I want to introduce you to the use of the null character as to mark the end of a string of characters.